PBR Automotive Proprietary Limited would like to welcome you to their second video in the series on passenger car braking systems. This video has been produced to aid you in diagnosing customer concerns relating to a spongy brake pedal. With this type of problem, customer concerns would most likely center around a lack of pedal height, sometimes called pedal reserve. During heavy braking, the pedal may even touch the floor and generally has a spongy feel about it. As a result of this, the brakes may not be able to provide sufficient stopping power. Having first verified that the pedal travel is excessive, the next step is to determine the cause. A spongy pedal is usually an indication that there is air in the system. Air may have entered through the master cylinder due to the fluid level being low. Low fluid level is often an indication of a hydraulic leak in the system, which has allowed the fluid to escape. These types of leaks are usually easy to locate and when found should be rectified immediately. Following this, the system should be refilled with the correct rate of brake fluid. And then bled to remove any air that may be present. Should there be no obvious signs of fluid leakage, a more detailed inspection will be necessary to establish the reason for air entering the system. Wheel cylinder cups, for example, deteriorate with heat and age, causing a loss of lip tension. When the brake pedal is released, a low pressure or partial vacuum is created in the hydraulic system. When this occurs, air may be drawn in over the sealing edges of the wheel cylinder cups. Cups in this condition should be replaced immediately with genuine replacement parts to restore the system to a serviceable condition. Another possible cause of a spongy pedal could be brake drums that have been machined past their maximum limit or even cracked. Both of these conditions will cause the drum to expand as the brake shoe is pressed against it and cause the spongy feeling. Drum diameter should always be checked against manufacturer's specifications whenever a braking system is being inspected or repairs are being carried out. Also, brake shoes are ground so that a small clearance exists between their ends and the drum when they first contact it. As the force increases on the shoes, they flex slightly, and the whole lining material then comes into contact. This is called radius grinding, and is done to prevent the shoes from contacting their ends first, which would cause squealing and grabbing. As brake drums are machined over size, the shoe lining radius needs to be altered to suit the new drum diameter. Failure to do this increases the clearance between the end of the shoes and the drum as its diameter increases. As this clearance increases, the shoe has to flex more, which in turn gives a spongy pedal. Whilst disc brakes generally have fewer problems than drum brake systems, there are still some conditions which can cause a spongy pedal. Pads can have excessive taper in either a longitudinal or radial direction. Also, the piston side pad can wear concave. This is caused by the backing plate flexing under repeated heavy braking conditions. Rear disc brake pistons may have been incorrectly positioned so that the dimple on the back of the pad will not line up with the slot in the piston. Both of these conditions allow the pad to flex as it is applied, leading to a spongy feeling in the brake pedal. Moisture, which is absorbed by the brake fluid over a period of time, can also cause pedal problems. Water enters the system through the rubber brake lines and lowers the vaporization temperature of the fluid. Under heavy brake usage, the high temperature generated form bubbles of gas within the fluid. This gas is compressible and consequently causes the pedal to feel spongy. Areas of high humidity or rainfall decrease the time taken for the fluid to deteriorate to a point where it becomes dangerous. Nowadays, there are several devices available on the market which will test the boiling or vaporization point of brake fluid. If, however, one of these is not available, a reasonable indication of fluid condition can be gained by removing the master cylinder reservoir cap and checking the fluid for clarity and color. Fluid which has become dirty and discolored has usually reached the point where it needs changing. Since the early 70s, the majority of motor vehicles have been fitted with dual-circuit braking systems. This provides an added complication due to the possibility of air being present in only one circuit. We must therefore be able to establish which circuit is causing the problem. Fortunately, there are two relatively simple methods that can be employed to isolate the problem circuit. The first method requires the use of an assistant to pump the brake pedal approximately 12 times and then hold the pedal down. The master cylinder reservoir cap is then removed and rags are placed around the reservoir to soak up any spillage. The assistant then takes their foot quickly off the brake pedal, and the fluid in the reservoir is checked for the amount of disturbance that occurs as the fluid returns from the brake circuits. Whilst a small amount of disturbance is normal, a circuit in which air is present, or which suffers from one of the other problems previously mentioned, will erupt far more. This occurs for two different reasons. In the first case of air in the system, the air is compressed when the pedal is depressed. When the pedal is released, it expands, forcing the fluid back up the brake lines more quickly than normal, and therefore will erupt far more. In the second case of oversized brake drums, or incorrectly assembled brake pads, we have a situation where there is abnormal deflection in the system, and therefore increased fluid displacement. With more fluid returning to the master cylinder from the circuit, the amount of disturbance in its section of the reservoir is correspondingly higher. The second method is to use brake hose clamps to isolate each wheel or pair of wheels. The clamps are then released one at a time, the brake pedal depressed, and the drop in pedal height noted as each is released. Whilst it is normal for the pedal to drop a small amount as each clamp is released, a large reduction in pedal height will immediately indicate where the problem in the system lies. If, on the other hand, the pedal travel was still excessive when all the wheel brakes were isolated from the system, the problem will most likely lie in the master cylinder. Master cylinder cups may have become soft or swollen due to fluid contamination, or have their sealing edges damaged by dirt which has entered the system over a period of time. Again, look for fluid discoloration, globules of other fluid, or cloudiness, and check the rubber diaphragm cap gasket for distortion. The presence of any of these gives a good indication that contamination has occurred. Once the cause of the spongy pedal has been found and rectified, the system will then need to be bled to remove any air that may be present. If the master cylinder was removed, it is more convenient to bleed it on the bench prior to refitting. The first step in bench bleeding is to clamp the master cylinder in a vise using soft jaws to prevent any damage to the body. Next, bleeder pipes are fitted to the fluid outlets, and the reservoir is filled with fluid of the correct grade to a level which covers the ends of the bleeder pipes. These bleeder pipes can be made from two short lengths of brake pipe, flared at one end, and with fittings to match the threads in the master cylinder outlets. The pistons are now pushed gently to the end of the bore and then slowly released. This process is repeated until no air bubbles can be seen rising to the surface of the fluid in the reservoir. A couple of tips that will help you with this process are, firstly, if the master cylinder is one of the fast fill or quick take-up variety, such as fitted to Falcon or Magna, Wait 15 seconds between piston pumps. If you don't, you probably won't remove all the air. And secondly, it's a good idea to use a piece of wooden dowel to push the pistons with. That way, should you slip while pushing, the wood won't score the bore of the cylinder. Once the master cylinder is bled, it can be removed from the vise and refitted to the vehicle. It should be noted that most Australian-produced vehicles use the booster output rod as the stop for the master cylinder pistons. This is done to reduce lost pedal travel and means that prior to tightening the retaining nuts, there will be a small gap between the master cylinder and booster. Having refitted the master cylinder, the bleeder pipes can be removed and the brake lines reconnected. At this stage, the brake lines should not be fully tightened, as a small amount of air is still present in the brake lines. To remove the last of the air, have an assistant slowly push the brake pedal down. When a steady stream of fluid can be seen flowing from both connections, tighten them to the correct torque specification. The master cylinder can now be used to pump fresh fluid through the rest of the brake system by bleeding at each wheel until new fluid comes out. This is done not only to remove air, but should the problem have been due to other causes such as fluid vaporization, it will remove all the old contaminated fluid. The bleeding sequence will depend on vehicle type, and manufacturer's recommendations should always be followed. It is normal for the brake failure warning light to illuminate when the ignition is switched on after some forms of manual bleeding. It will, however, go off once both systems have been bled and medium pressure has been applied to the brake pedal. This centralizes the pressure differential warning switch spool in its bore and switches the light off. There are several common methods of bleeding air from braking systems. Some can be performed by one person, and some require the use of an assistant. We will describe each method in detail, but before we do, there are some things worth mentioning that relate to bleeding in general. The first is that air always rises to the high points in the system. Sounds simple, but think for a moment about the implications of that statement. If someone has swapped the calipers on the car that you are working on from side to side, the bleeder screws will be at the bottom. Because the air will rise to the top of the caliper, you would never be able to remove all the air. In a similar fashion, the hydraulic line which rises up for a distance, such as where it travels over the top of the rear axle housing, will also be a place where air would naturally collect. Not all types of bleeding methods will cope with this problem, and is the reason why we are presenting several methods to you. Manual bleeding is best performed using two people. With this type of bleeding, a flexible tube, preferably transparent, has one end attached to the bleeder screw and the other immersed in a container partially filled with clean brake fluid. The bleeder screw is opened, and the brake pedal is slowly depressed about halfway. The bleeder screw is then tightened, and the pedal slowly returned to the rest position. This process is continued until only clean fluid, which contains no air, can be seen leaving the bleeder. There are several things to note about this process. The pedal is only pumped slowly. This gives time for the master cylinder to recuperate and prevents the fluid becoming aerated due to rapid pedal pumping. Secondly, the bleeder screw is always tightened before the pedal is brought back up again. This prevents the master cylinder from drawing old fluid back into the system. Thirdly, when bleeding a master cylinder that has not been overhauled, care must be taken not to damage it during the bleeding process. Dirt accumulates over a period of time at the ends of the bores where the piston cups don't normally travel. If the pistons are pushed to the end of their bores, this dirt is picked up by the cups and dragged back up the bore, damaging both their sealing lips and the cylinder bore. And finally, a tip. If the bleeder hose is looped up above the bleeder screw before being immersed in the fluid container, it is easier to see the air leaving the system and always leaves a head of fluid at the bleeder screw. Another form of manual bleeding is called surge bleeding. This method is often necessary when brake lines have large risers in them. Or loop around the backing plates from one wheel cylinder to another. It again requires two people, and as before, the bleeder screw is opened, the pedal depressed, and the bleeder retightened before the pedal is released. The main difference is that when the pedal is depressed, it is pushed down rapidly and then returned slowly. When the pedal is depressed rapidly, the fluid travels through the lines more quickly and carries the air trapped in the high points with it. However, the same problems associated with pushing the pistons to the bottom of their bores apply here as they did before. To overcome this, a suitable chock can be placed under the pedal to limit the distance it travels. When using a pressure bleeder, a specially designed adapter is attached to the master cylinder reservoir. The system is then pressurized by a pump, which is attached to a drum of new brake fluid. And each bleeder screw opened and closed in turn until the system is free of air. The adapter is then removed from the master cylinder, and the reservoir topped up to the correct height. The final method of bleeding we shall discuss is called gravity bleeding and requires only one person. With this method, the master cylinder reservoir is filled to the correct level with the specified grade of brake fluid and the cap replaced loosely to minimize moisture absorption. A flexible hose is then connected to the bleeder nipple in the same manner as used in manual bleeding. Again, it's a good practice to loop the bleeder hose above the bleeder screw before placing the end in a suitable container. The bleeder screw is then opened and the fluid simply flows through the system due to the master cylinder being higher than the bleeder screw. Bleeding sequence should follow manufacturer's recommendations, but in the absence of those, starting from the bleeder screw furthest away from the master cylinder is usually the best method. It should be noted that this method is time-consuming and that the reservoir must be constantly topped up. Also, this method will not remove air from systems where there are loops in the pipes, as described before. That brings us to the end of this video on spongy brake pedal diagnosis. But before we leave, let's just recap on what we've learnt. Air may have entered the braking system due to low fluid level in the master cylinder reservoir. This, in turn, could have been caused by an external leak somewhere in the system. Air may be drawn into the system over the sealing lips of deteriorated wheel cylinder cup seals, caliper seals, or loose connections, when during normal operation the pedal is released quickly. Air or gas bubbles may form when deteriorated or contaminated brake fluid suffers vaporization. This condition is accentuated by heavy brake usage or a dragging brake, causing a heat build-up to vaporize or boil the fluid. Tapered pad wear, incorrectly fitted brake pads, or brake shoes with the wrong radius produce additional flex in the system, causing a spongy feeling in the brake pedal. And finally, drums which have been machined beyond their maximum limit or have cracked during service expand when force is applied to them, again increasing pedal travel. PBR Automotive Proprietary Limited hope that this video has been of assistance to you in diagnosing spongy pedal problems, and would like to draw your attention to the other videos on brake diagnosis available in this series.